Good morning and welcome to lecture 13 on the power rule. So the power rule, which we briefly introduced in the last lecture when we were talking about the derivative, sketching derivatives and some derivative rules, is going to help us take the derivative of polynomials when combined with those rules about taking the derivative of sums and differences and factoring out constants. All right, so let's start. First of all, let's recall the power rule. If we have d by dx of x to the a, then we are going to take this a down and subtract 1, and that is going to give us the derivative. So if we have x to the a, the derivative of that is a x to the a minus 1. All right, to see how this plays out in a couple of examples, if we have d by dx of x to the fourth, then we're going to take that 4 down and subtract 1, and we end up with 4x cubed. So if the exponent is positive, then this is what we get. The same thing plays out if the exponent is negative, rational, or irrational. So suppose we have x to the minus 4. So remember that if you have a negative exponent, that is the same thing as taking the ratio of that. So this is the same thing as that. So now we can take not only the derivative of exponential functions, but of fractions, like that. So you're going to take x to the fourth, you're going to take that minus 4 down, the whole minus 4, so you have minus 4, and then you're going to subtract 1, so you have minus 4 x to the minus 5. Now, what happens if we write this in the other form? We have minus 4, 1 over x to the fifth. So now we can take the derivative of powers and of fractional exponents. Okay, what if you have a fraction in the exponent? Now, the same rule applies, so don't be misled by the fact that this is smaller than 1, so if you're subtracting 1 here, you're going to end up with a negative number. So if you have 1/3 in the exponent, you're simply going to take that whole 1/3 down, you're going to end up with a 1/3 on the outside, and you're going to subtract 1, and so that you end up with 1/3 x to the minus 2/3. So recall that if you have a fractional exponent, this is the same thing as taking a root. So if we have x to the 1/3, that is the same thing as taking the cubed root of x. And what we end up with is 1/3. Now we have a negative sign here, so we have a ratio, 1 over, and we have x to the 2/3. Okay, how do we write x to the 2/3 in a different way? Well, we still have x squared. We have x squared, and then we have the third. So we have the cubed root of x squared. All right, so you can simply follow the power rule, or if you have the derivative of a root, you can rewrite that root as an fractional power, and then take the derivative. All right. Finally, the same thing applies even if the exponent is an irrational number, such as 2 pi. In this case, that whole 2 pi comes down, and we subtract 1. All right, there's no easy way to write 2 pi minus 1 as another irrational number, so we're just going to leave it in that unreduced form. All right, so some examples. Let's take the derivative d by dx of 1 over x squared. Note that this is the same thing as taking d by dx of x to the minus 2. All right, now we use that power rule. We're going to take that minus 2 down and subtract 1. So we have minus 2 x to the minus 3. All right, now we talked about this one just up above, where we have d by dx of the cubed root of x. This is the same thing as saying d by dx of x to the 1/3. We're going to take that 1/3 down and subtract 1. So we have x to the minus 2/3. Now we're going to rewrite this, and we have 1/3, 1 over x to the 2/3. Now I'm going to rewrite this one more time. 1 over x squared to the 1/3, which is equal to 1/3, 1 over the cubed root of x squared. All right, so just this one power rule gives us a lot of options. We can take the derivative of a term of a polynomial, or we can take the derivative of a root or of a fraction. All right. Now, to take the derivative of a full polynomial, we have to combine the power rule with some other rules. So the first one is that the derivative of some constant a is equal to 0. Recall this is because the tangent line is flat. And so it doesn't matter what this constant is. If we have d by dx of 3, then that constant is equal to 0. The constant doesn't even have to be known, so imagine that we're taking d by dx of some unknown constant r. That derivative is still equal to 0. All right, now here is the cool part. If we're taking the derivative of some variable t, but with respect to some other variable x, so we often use t as the variable for time, but if we're taking the derivative with respect to x, for example, distance, this t is effectively a constant. So math doesn't know that this is a variable or a constant, and you're taking the derivative with respect to x, and so t just appears as a constant, and so this is equal to 0. So we can combine these rules, and you're going to have to watch what you're taking the derivative with respect to, because if you have rt squared, then the derivative of this with respect to x is simply 0. So pay close attention to what you're taking the derivative with respect to. All right. So I know we've been just throwing it as d by dx or d by dt all the time and not really paying attention to what we're taking the derivative with respect to, but now we have to start paying attention. All right, now, if we have a constant factor, if the constant is not all by itself, but is actually a constant factor multiplied by some function, we just can factor that constant out. So this plays out in a number of ways. If we have 3x squared, then this is simply 3 times the derivative of x squared, which we did last time to be 3 times, now that power comes down, 2 minus 1, so we have 3 times 2 to the 2 minus 1, which is x to the first power, which reduces to being 6x. Now, the same thing applies when you have an unknown constant, that unknown constant r just gets factored out, but it's a little bit less easy to simplify, and we end up with 2rx. And finally, once again, you have to pay attention to what you're taking the derivative with respect to, because this t, even though sometimes we use t as a variable, t in this case is not our focal variable and is simply a constant, and so simply comes out as a t. All right, so then we have the derivative of a sum. The derivative of a sum, d by dx of f of x plus g of x, is simply d by dx of f of x plus the derivative of g of x. So once again, this comes from the fact that the derivative is a limit. And remember that the limit of a sum was the sum of the limits. So we have the same thing when it comes to derivatives, that the derivative of a sum is the sum of the derivatives. All right, so what do we get here? Another way of writing this is in shorthand with the prime notation. So if u plus v prime is u prime plus v prime. All right, so combining the rules that I've talked about up above, we can now take the derivative of a polynomial. So suppose that we're taking the derivative of the polynomial 7t to the 4th plus 3t squared plus 1 with respect to t. Note that we're taking the derivative with respect to t, so this t here is not a constant. It is our focal variable. So the first thing we can do is we can split up the sums using this last derivative rule, that the derivative of a sum is the sum of the derivatives. Now, we can factor out the constants. We're going to factor out this constant, this constant. Now here we're taking just the derivative of a constant. So this term simply directly goes to 0, and we end up with 7 times the derivative of t to the 4th plus, factor out that 3, d by dt of t squared plus this constant, which is 0. So I could put in a plus 0 out here, but that will go away. All right, now we're going to combine that with the power rule. So we have a power to the 4th and a power to the squared. So we have 7 times 4, that 4 comes down, and we reduce the power by 1 to get 3, plus 3 times 2 reduce the power by 1 to get t to the first power. And so our solution is simply 28t cubed plus 6t. Hopefully I did 7 times 4 correctly. Okay. That is our solution to our derivative. All right, with that, I'm going to let you do the self-study and practice those derivative rules that we got.